Hey everyone, happy Thursday. We are almost to the end of the work week. We are almost to Christmas too. We've got literally 10 days before Christmas. And David, what's going on? Winter geeking is the best. We are going to be absolutely doing that. Let's get this bread, Dan, the bread and milk, huh? We'll see about that. But I will say this: it's time to take the Arctic plunge. Temperatures are going to be cold. So cold, in fact, I'm a little concerned because, just recently we moved into a new house and we have a pool, and it's a pool that you can't really close because you have kind of the things flowing from the pool, hot tub to the pool. And so I don't really how to handle it with the cold. So obviously you got to keep the water flowing so it doesn't freeze. You don't want your pipes to freeze, but it is going to get cold and we've got to watch it. So I'm going to do a quick Facebook live. If we get a lot of interaction, a lot of people ask questions, I'll stay on here as long as it takes. But we've got some interesting weather coming our way. Let's dive into it here first of all with the weather pattern right now. I mean, yes, the severe weather was pretty tremendous over the last 2 days. Yesterday, today, even today in Florida, there was severe weather. And then off to the west, you had severe weather on Tuesday in the Oklahoma area, as well as in Wayne, Oklahoma. Now that was a little unexpected, and so here's the deal with this: is that we played it a little cautious, maybe a little too overly cautious, but we knew that system would be trouble for someone somewhere. It was for Wayne. It was for Dallas Fort Worth. Man, there were tornadoes all over. In fact, another tornado is going to be added to the list in the Dallas Fort Worth area. And the reason for that is because I actually learned about a potential track that came through south of Jacksboro. So all right. So the reason it's so breezy right now is because we got this low pressure system that's to our northwest, as you can see, northeast, should I say, and to southwest we have this high pressure system. So we're sandwiched in between the two, and with this high building in, it's pretty breezy. Look at what's happening in the Texas Panhandle. A little bit of precipitation coming. That was not predicted at all by the models today. It's not a lot, but it's cold and it's a little wave of energy, and it will bring a little extra cloud cover for us as that system swings in. Shouldn't affect the temperatures too much. But going back to our map here, if we look off to the west, you're going to see our next storm system. So here's the deal. We are going to get a little bit of precipitation that's coming our way. And this is going to bring the potential for some snow, as a matter of fact, as early as Monday. So snow potential is starting to crank up. You're going to see Monday's system. There it is, a big spin in the jet stream. And that Monday system is going to be marching east. And let me track this for you. So there it is, dip in the jet stream as it moves eastward. You see that little dip that's taking place. That's a little wave of energy that swings in. And by Monday morning, it'll be snowing. Now, here's the deal. We do not have very cold temperatures at the surface. And because we don't have cold temperatures at the surface, this isn't going to be a major, snowstorm. But I do think we see some snow, and then it changes over to some rain. But look at this. This is some cold weather. And I'll show you. I didn't show it on the newscast tonight, but I'll load up the computer models and I'll show you just how cold this does look. So definitely some chilly weather that's headed our way. Now, if we look at, first of all, the 8 to 10-day outlook, first the 6 to 10-day outlook. I mean, you can't literally get any more purple than that. I mean, look at this. This is at the bottom of the scale here for the probability of being below temperatures, below normal, is almost 100%. Much colder than normal. Then you got farther west, you've got above normal temperatures, big dip in the jet stream that's taking place. Now, when we look at the 8 to 14-day outlook, we're still colder than normal. Do you see how the West Coast is much warmer than normal? That is a sign that we are going to have what's called cross-polar flow. And so cross-polar flow essentially is where the jet stream goes way up into Canada and then drops almost straight south. And that's exactly how this is going to be. Now, that is going to provide some really cold weather. So let's look at this snow that's coming in, and we're going to dive into this. So first of all, the temperatures are going to be marginally freezing. So we're going to have marginally, almost said marginally severe because I'm so used to saying marginal and severe. But here's this system that's coming in Monday morning. Don't be surprised because this has a little bit of moisture to work with, that because the atmosphere is so dry, there's going to be something called evaporative cooling. Evaporative cooling, what it does is it essentially causes the temperature to drop in the column. This is going to be from the top down. That's going to drop our temperatures and eventually change this precipitation and start it off as snow. So it will be a little bit of snow in the morning. It's going to be mainly on elevated surfaces, grassy areas. Then, as you'll see here Monday, late morning into the afternoon, that system starts marching eastward. So it's a quick mover. Now, how much snow are we talking about? Well, if it all accumulated, it would be around an inch. Now, I think the higher elevations will see about an inch. But remember, that's going to be on elevated surfaces, car hoods, grassy surfaces, all that stuff. And so you're going to see all that for the higher elevations, some precipitation. Now, when we look at the GFS, it's a little bit of a different story. Notice no precipitation at 2 a.m. and then all of a sudden this little wave comes in. It's a fast-moving wave. There's no doubt about that. And we will see snow. But notice how those temperatures start warming because we're going to get out of the southwest. Anytime a system comes and it's northwest of us, you may get snow initially, but it will never stay as all snow. And I think there's going to be some sleet mixed in too as well. So then this model kind of keeps it around a little longer and then it kicks it out. So how much snow does the GFS show? Just about the same. And as a matter of fact, this actually updated just recently and it shows even less, but it shows some spots picking up more. I think around a ½ inch to an inch. That's definitely not anything to write home about on elevated surfaces and grassy areas. Now, let's geek out and show you how this works, because I think this is going to be kind of cool to show you. So this is a skew T. I'll take my camera off the screen. But what you're looking at here is a skew T. And so on the cursor, you can see this on the screen. This is the temperature line as it goes up with height. This is the dew point line as it goes up with height. When those two are very far separated, you have some really dry air and what's known as a low relative humidity. So that's what you're seeing there. Now, what's going to happen here is that as we go along in time, this, by the way, is Sunday afternoon, so everything's pretty dry. Now, watch what happens as we go along in time. This is, remember, a computer model, but you're going to see this column start saturating. You know what this is? This is snow that's starting to fall, ice crystals in the clouds. These are some high-level clouds. So the cloud cover will be increasing on Sunday night. Then you're going to start to see this start to lower even more. Notice how that is starting to essentially what's called saturate. But it's still really dry in the low levels of the atmosphere. But this right here, see this little area? This is between -10 and -20 degrees Celsius. -10 and -20. How do I know that? Well, here's the temperature line at -10 called the isotherm. Here's the -20 degree isotherm, which is skewed. This is why it's called a skew T. Notice how we're looking at Fayetteville's area. And this is, by the way, BuffKit. BuffKit's a really good program that will help you look at essentially computer model soundings. It's a little antiquated. It's a little hard to use. But as we move along in time, this is Monday, 1 a.m. Here's 2 a.m. Here's 3 a.m. And now look, it's starting to show this little blue dot here, snow. Why is that? Well, this is starting to saturate. Did you see how the temperature dropped too? So this is the freezing line. Anything to the right of this line is above freezing. Anything to the left of that is below freezing. When your temperature and dew point are really close together, they're saturated all the way up, and it's below freezing, that's snow, obviously. Right there, that's snow. Now, because it's very close to that freezing line, that's where that margin of error happens. So this could be a heavy wet snow and massive flakes, because right here, this is an extremely heavy snow. Now, I do have reserves about this computer model because it shows at here, the temperature is crossing the dew point line, and that can't happen. The dew point can never be above the temperature, but it is right there. And so that's a little bit like, okay, well, maybe this model is a little off. Regardless, though, you're going to see over time, then that dry air starts kicking in and the temperature starts warming. And so here comes that essentially dry air that works its way. The ice crystals start disappearing, and then there's over time. That's what happens with your SQT. So let's go back and look at that again. So again, very dry. And then as you'll see here over time, that precipitation starts making it to the ground. Isn't that kind of cool? And then you'll see it saturate. It's called wet bulbing. And so wet bulbing, the temperature is where the temperature rises about, or the temperature drops about 1/3. The dew point rises 2/3. They meet in the middle, and that's called your wet bulb temperature. In fact, I'll put it on the screen. That's the blue line right there. There's your wet bulb temperature. See how cold that is? That's all below freezing, even though the temperature here is above freezing. So that is how it's going to start. And then you'll see over time that starts to warm a little bit. Right there, it turns to a rain. So I do believe during the late morning into the afternoon, we'll start to see some precipitation that becomes rain instead of snow. And then there it's all rain. So we have a snow to rain mix. And maybe even some sleet too, because sometimes the models don't handle the warm nose quite as well. But that's what we're kind of looking at, and then that precipitation is out of here. Now, what I can do is let's go to 180 hour. Let's see. So then this is the GFS. So this is after that snow. And then this is a little sneak peek of what happens. Here's Christmas, the day. Okay, so this right here is the next system that's coming in. This is the 22nd. This is what the GFS shows. There's snow. And notice how cold it is, too. It shows a big old cold front coming in on Thursday. That is, first of all, a very cold snow. And when we look at the ratios on this, you're going to see it going way up. So basically right here, it's not very great. We go back to, so these are all things that we look at. I got to take the camera off the screen so you can see those ratios. Whoops. Hi. All right, let me go back to this. So this right here is Thursday, and those ratios climb up to about 15, and then it kind of drops off a little bit. Oh, here we go, 180. Let's see here. Yeah, so Thursday, here you go. You read it from left to right. So there is right over here. This is, in fact, all of your precipitation with the cold air. Notice that's a 15 to 20 to 1 ratio. So definitely a lot that's happening. And when we look here and drag this over, that's showing about 3.2 for this system coming in Monday to Tuesday. And then there's the system 2.1. So yeah, it does have some snow. So if we close that out and go back to the sounding, let's see what it looks like in Fort Smith. So here's the GFS model. There's the wet bulbing on Monday. And see how it wet bulbs, but a wet bulb's kind of right above freezing. So maybe a little bit of snow, but not much. It's not cold enough. Now, when we go over to Harrison, let's see what that looks like. So there's the wet bulbing. It's already starting to snow essentially by Monday morning. And that's not really a freezing rain profile. And then you can still see it's got a little bit of light snow, and then it's gone. So anyways, that is some really, really good stuff right there. So the dendritic growth zone when forecasted, that's a great question right there. Let's go to some questions here. Sounds like I had some bots on the chat. So with northwest flow, don't models have problem picking up winter weather? Yes, they do. And that's exactly why we don't know exactly what's going to happen towards the end of this end of this forecast cycle. So what's the best dendritic growth zone values when forecasting snow? Well, the best is -10 to -20. That is your degrees Celsius, and you want a saturated column within that dendritic growth zone, which is -10 to -20. So you look at the sounding and you see if you have saturation at that point, then you are going to get those big dendrites, which is the snowflakes. What's interstate look like for those travel? I've been worrying about them. So I don't think there's going to be many issues with the interstates unless we get a burst of snow that happens and it's pretty heavy. All right. So Magic 8 Ball for Christmas. We're not going to do that quite yet. I'm doing a little more than just Magic 8 Ball this time. Well, I think a lot of people think that's all we do and that's all we look at. And it is fun. But, we also do put some science behind it a little bit. So let's look at the latest winter, and let me show you why I'm doing this. So here is my latest map that I made. It's a white Christmas chances, and you can see over Northwest Arkansas that typically when we put this into motion here, see that blue? You can barely see it on the screen. That's a 10 to 25% chance. Really, honestly, it's right around 10% chance for us. Maybe in the higher elevations, it's a little bit greater, and the dark gray is a less than 10% chance. So when we zoom in, you can kind of see that a little bit better. However, this year, because we know the cold's going to be in place, and because I'm going to show you some ensemble forecasts here coming up in just a bit, there is a good chance that winter weather with the cold will be impacting us before Christmas or around Christmas, which will lead to the potential for a white Christmas. Now, I know that this is premature. I know that Alex Bogard says it's too far out to know, which is clearly the case, but it's not too far out to know that it's about to be really cold. Also, La Nina is still in effect. This is a La Nina winter. La Nina winters bring very active, highly amplified progressive weather patterns. This is what I have so far. I just kind of drew it out. And I think that, yes, there's still that 10% chance for areas farther south, but honestly, that might even be going up. 20% for Fort Smith, and that could also be going up. Again, I'm being real conservative here. This is even conservative for that. 30% for Tahlequah, St. Paul, Fayetteville, Concord, and then about 40% for Benton County, Bentonville, Rogers, Bella Vista, Gravette. So that's what we're kind of looking at in Southwest Missouri, Roby. I think it's looking pretty impressive. So there you go. There's your white Christmas chances. And if we look at the odds here with my odd meter, it's getting up to 40%. Now, you're like, Dan, it's 10 days out. You don't know what's going on 10 days out. That's not really happening. Yes, true. I don't know exactly what's happening 10 days out, but I can tell you that the signals are there for a system or systems to come in with that cold air. Case in point, here's what we're going to do. We're going to show you some computer models, and not just computer models. We're going to show you what's called ensembles. Now, ensembles, I put this out as a tweet, and so I'm going to load this up real quick. If you didn't get to see this, it's a really good example of long-range forecasting. All right, so I'm going to start off with this, okay? I'm going to start off with this long-range forecasting. So let me know if you're bored out of your mind, and if you are, I could shut it down. But here's what we've got. All right, this is my Twitter at WeatherDan. If you don't follow me, then well, you can if you want. But I'm gonna go ahead and show this thread here. So first of all, when looking at long-range models, it is a wise decision to use what's called deterministic models. Excuse me, ensemble models, not deterministic. And here's the reason for that. The reason for that is because I'm going to show you exactly why. So first of all, deterministic models, they only show one solution, what's expected to happen at one time. So it's said like a snapshot or a frame. Now that solution in a deterministic model can change with each model run. So for instance, sometimes you see a post on social media and it's shared 400 times showing a 4-foot snowstorm. And then the next time you see it 6 hours later, it's gone. So for instance, you have a tremendous amount of variability with this, where it goes storm to no storm, and here's an example of a deterministic model loop. This is for December 22nd at 6 a.m. from the model last night. So if you can see that, I can click on it and kind of pause it on some of the images. So first of all, I missed it. It's a little delayed here. Let's see if I can get it. So I want to show you this variability. Now it looks like it's moving. There you go. So from the computer model run on Monday, basically 6 o'clock in the evening, Monday the 12th, this is what it showed. Giant snowstorm. Okay. 6 hours later, it's gone. 6 hours after that, well, it's still in a little bit of snow, but it's kind of gone. 6 hours after that, it's gone. And this is not moving the model. This is not moving the time. This is keeping the time at the same time and showing what's called a model trend loop. There you see the snow that's falling, and then it's gone, and then it's back, and then it's gone. So here's the deal. If you're looking at this going as a deterministic model forecaster and you're changing your forecast every time you see that, that's bad meteorology. So as we said, each frame of that GIF or GIF was the GFS predicting the forecast at 6 a.m. on the 22nd of Thursday, December, which is basically varying quite a bit. So a great example of a deterministic model is, let's say I want to see how good of a free throw shooter you are. You know, the Razorbacks playing this Saturday in Little Rock, North Little Rock. If I gave you 2 shots and you made them, and I'd be like, all right, he's 100% accurate free throw shooter. Well, that's not a very big sample size, but essentially that's what people are doing when they post these model forecasts that are 384 hours out showing these snow totals. It's not very accurate, and it's not a good way to do that. A better way would be to get all of the free throws over a game or over a season and then check out your average. Well, that's what you do, right? As a basketball player. And so that's called an ensemble. That's what a computer model ensemble is. So what they do is they run that solution, they tweak the model by altering a variable, and then they run that solution again. And so with multiple solutions, with changing one of the members, that's what gives you an ensemble forecast, kind of like an average. And so this is what I'm going to show you. This is an example of an ensemble forecast. This is the one from yesterday morning. So what you're going to see first of all are these ensembles. There's 50 ensembles or 50 members, excuse me, in an ensemble. This is the European ensemble. This is for Drake Field. On the left is where the time starts, and as you go to the right, the time goes farther out in advance, or the time increases. So this right here, 12Z, the 25th, is Christmas morning. So anywhere at this line is Christmas morning. To the right, after Christmas, before Christmas, to the left. This is 6 a.m. Monday. So this system that's coming in 6 a.m. Monday. All this to the left is no snow. Now you have to imagine there's 50 lines on this, because sometimes you don't see lines here over to the left because there's no snow to represent it. But if you notice, look at how many of the members are showing precipitation or snow. We'll look at the latest one too. There was only 3 out of the entire period of the month of December that did not show snow. Almost every single one had at least some type of precipitation. So then we look down here and you see the control. The control run is essentially the least out of them, all right? And then you see the mean, which basically shows on the 25th close to 2 inches of snow by the ensemble. Notice what happens as the control run goes nuts after Christmas with, by the way, some really cold air. Okay, so that's an ensemble forecast. So if we go back, here's the GFS ensemble. Notice no snow, but then all of a sudden the snow starts Monday. And then the snow could pile up. These, by the way, are in inches. So you see 0.5 and then 2.1. And then you can see the mean, and you can see the control, and then you can see the amount. Now, one of the model members is showing 27 inches. One of them is showing 2.2. 27 seems a little far-fetched, right? Well, guess what? that might be the deterministic model one time that shows that. Guess what? That's going to get posted everywhere. Is that what's really going to happen? Probably not. And you can see the averages on how much they change. So, with that being said, let's look at the newest one and see how that works. So, what we're going to do is we're going to go into the mediagrams. We're going to go into the ECMWF ensemble and we'll go into total snow. Now, this only goes out to 90 hours because this is the GF. This is the European at 18Z. We'll get to the 12Z and I'll show you that. But I take it back. It goes out 144. I guess they upgraded that now. Yeah, that goes out 144. It didn't never used to do that. It used to only go out 90. Now it goes out 144. And so it goes out to Wednesday. And you can see that really there's not a whole lot of precipitation that happens after this Monday system before Thursday. And notice the amounts are pretty low, but it does show snow, and most of them do. So let's go to the 12Z and get a little bit farther out and see what we got now. So now here's the 24th right here. So basically the night of the 23rd. Here's the night of Christmas Eve. And then here's Christmas Day morning. Look at this. 1, 2. Only 2 members out of 50 do not show precipitation, do not show snow. That's a pretty good sign that something's going to happen. If we look at the GFS ensemble, the total amount of snow, like I said, man, we're geeking out here. This is the 18Z model. And by the way, we can run back and we can look at the amount of consistency. Check this out. Nothing changes. It's very insistent that something is going to happen. That's snow. It's all snow. Now, sometimes the model's a little overdone, as you know, and it goes a little crazy. Now we're going to look at this. The amount of snow, the percentage of snow exceeding 1 inch. Okay? So let's see what we've got here. For the probability of snow exceeding 1 inch for this Monday system, pretty low. Doesn't look like it's going to do it. I'm going to zoom in on Arkansas so you can see what we've got. I actually can't, but I can do a south central region so you can get to see. All right, so there's a probability of that reaching 1 inch. Doesn't look very impressive. Then as we move along in time, still doesn't show much, does it? However, remember this only goes out 144 hours. So now we got to go out a little farther. Watch what happens. So there's December 24th. There's December 25th. I'm going 40%, which is pretty conservative because this is going 50, 60, even 70. See how it's got a couple of spots there, the oranges, and even the dark orange. And by the way, I don't know if you saw the United States. Look at the United States. There is one heck of a snowpack that's developing to the north. Now, if we look at snow depth, here's the snow depth. Wow, there is quite a snowpack developing to the north. So that's one thing that's going to tell you that the temperature is going to be really dang cold. Let's look at the ensemble forecasts. So this is ensembles for after Christmas Day. Those blues and turquoises and man. Yeah, that's cold, man. 4 below. That's an ensemble forecast. That's Celsius. Never mind about that. There's 25. I was going to say that was really cold. That looked kind of scary. So this is an ensemble forecast, meaning the average, you know? So this is like basically what's the probability of the temperature reaching 0? Let's see. If we go to a south central region and we'll look. Well, it does have some probability, but it's a little bit north of us. So, but then you look at the GFS. I'll show you the GFS model. It's a little bit colder. So it does have that probability of reaching 0. By the way, this is the 18Z. Oh, it's a 0Z now. Well, let's see what we got for the new 0Z model that's coming out. And remember, this is the ensemble forecast. So let's see how it's doing with precipitation. So we'll look here. Surface winter, probability of snow exceeding 1 inch. And so there's the system for Monday. So if anybody's calling for 1 inch, it's about a 10 to 20% chance. So I think it's going to be around a half inch. Then you'll see this next system that's coming in. And so there's the GFS showing more snow potential. So I'm not just looking at one model. I'm not just rolling the 8-ball. I'm looking at a lot of different stuff. And so just basically breaking it all down. I know that's kind of some super geeking out. And maybe I lost you. Maybe you got bored. But I just wanted to kind of show you a little bit about what's happening with this system. Okay. I can identify with the basketball analogy. Cool. Just go for the half court shot. That way you look cool even if you miss. Yeah. True. All right. No doubt Arctic air is moving in to stay. What's the chances of other ingredients moving in? As you saw, the probability is pretty good. But we'll see. 5-10 inches or bust. Yeah, that's a long ways. Please tell me that we're going to have. Yeah, I hope it's not that cold, Roby, but man. All right. Wow, that's a huge front. Yeah, that's a long ways. I haven't done that. Now, Louisiana got rocked by tornadoes yesterday for sure. Wow, it's a huge cold front. It is. It absolutely is. And it's a really strong high too. So we really have a chance of snow. We do. I mean, you saw it. Very cool. Cool. How do you explain El Nino bringing us warm Christmas last year? So remember, it fluctuates. You remember what happened in January, right? It got freaking cold. That happened after a very warm December. We were in a blocking pattern with a ridge, and the ridge of high pressure kept those temperatures really warm. And so remember, with a La Nina forecast, with a La Nina, you get very highly amplified weather patterns. You get blocking patterns, all that stuff. Let me show you here. I'm going to remove this scene camera here. So delete. And if we look, so first of all, whenever you have zonal flow in the Pacific Ocean, this right here is called high angular momentum. High angular momentum leads to what's called buckling of the jet stream. And you can see that happening over time. So what happens is a ridge of high pressure develops. That ridge of high pressure creates really cold air from Siberia, by the way, that's going to be marching this way, heading this way. The Arctic Oscillation also heading this way. And so let's zoom out a little bit more, and then you'll get to see that jet stream pattern kind of evolve. So first of all, there's zonal flow. There's the ridge of high pressure. See that building? And then that buckling of the jet stream takes place right there. That allows that cold air to plummet south. So it's essentially like taking a bucket and dumping the air straight south. That's cross-polar flow. That is some really, really, really cold weather. Now, the European isn't as cold as the GFS. So why would that be? Well, probably because it doesn't show quite as strong a cross-polar flow. Now, I can't confirm that. I haven't looked at that, but let's check that out real quick. So let me look at the GFS 10-day, and we'll take a look here. Let this load up. We'll zoom out. And so there's, again, zonal flow out in the Pacific, high angular momentum. Look at the ridge building into Siberia. So look at that. That right there is the bottling up of some really cold air. And then that allows that to translate down with the ridge. It builds back up again. So this cold air is poised to plunge south. And then you're going to see that as that happens. Now watch. If I zoom out here, I bet you we're going to have almost perfectly cross polar flow. And there it is. That goes almost all the way up to the North Pole. The North Pole of where Santa is at. And then you've got that Arctic air just dumping south. And look at this too, prolonged cold. Not just a few days, prolonged cold. Remember, you look at those ensemble forecasts, and if we check them out, we can look at that and look at the mediagrams of the ensembles, which I like looking at because it's a little easier to understand. And we'll look at the multi-run temperatures. That's really hard to see. That's really hard to see too. That's not hard to see. So that only shows a very small cold blast. Seems a little too quick to warm, in my opinion. Oh, is that changing anymore? Nope. I know you're not seeing it yet. That's because I want to bring it up first. Okay, so yeah, I'll bring this up real quick. I'll show you what this is. So this, by the way, is is another one of those ensembles. Remember, each model run, each member is a line. This will make you go blue in the face. But you'll see here on Friday, you see a lot of numbers in the single digits and teens. And you can see that on the color scale here. And then you get into the purples and you get even colder. Now, if you look at this, this is called a box and whisker plot. So you have essentially your mean, you have your control, which is the kind of the more tepid of the two. And then you've got the variability in the ensembles. Notice how as you get farther out, the variability increases even more. So now you got fluctuations morning, afternoon, morning, afternoon. You can kind of see that warming that takes place. However, there's still a chance that it could stay pretty cold. So, but probably not out of the realm of possibility, but very close to it. So if we look at this, this is the ensemble showing some really cold air right before Christmas, and then it has dramatic warming. Now that just seems a little too quick to me. And typically, the Arctic air masses are much colder than what the models expect. It's always colder. Now, here is the GFS ensemble. We'll let that load. And so it shows really cold right around the 23rd next week, late next week. Then it shows that warming again, which makes sense because you've got this ridge of high pressure that builds in to the west that's going to be moving this way. And so there's the 6 to 10 day outlook and the 8 to 14 day outlook. So, all righty. So for Northwest Arkansas, just to let you know, the number of white Christmases is 7 since 1950. I've got a graphic for this. And so, first of all, here's some pictures of that white Christmas. I know it's what you're seeing here is just a black screen. Let's go back to it now. And so this is a 2009 was the last white Christmas in Northwest Arkansas. There you see it, December 25th, 2009. Some pictures from some viewers. Nice little snow. So if we look at those records, 2009, 2002, 1990, 83, 75, 66, 63. So on average, about every 10 years. Now, the records go back a lot farther than that for Fort Smith. They don't for Fayetteville. And honestly, there's a lot of white Christmases that are missing too in the records as well. So, what makes the El Nino versus El Nina? Well, it's La Nina and El Nino. So, let me show you that. That's a great question. If you're still on here, I'll show you that as well. So, first of all, what is La Nina? Well, here is La Nina. La Nina is where the temperatures at the equator west of South America are cooler than normal. So the Pacific Ocean west of South America in the 3.4 region is cooler than normal. So what does that do? That causes this type of weather pattern where you've got a ridge out west, an Aleutian high, essentially, the Pacific Decadal Oscillation. You got the polar jet stream, and then you got that cold air. Now, notice that you've got the jet stream tracks that are kind of flowing right over us, typically on average. So that is exactly why La Nina winters are so and La Nina springs are so active. Severe weather, winter weather, all that stuff. So that kind of gives you an idea of what happens. So you have essentially very dry air or very dry conditions along the Texas and Oklahoma area. And if we look at the drought and the drought index, if you want to see that, I'll show you that real quick. And you can see that it's pretty much following that. Let's bring up the drought monitor here, and we'll take a look. Throw this in real fast so I can load up some roads on or some places. And you can see that definitely some improvement in the drought, no doubt. Oh, today was the drought too, and you can see it's gone. There is no drought. It's not even abnormally dry anymore, so that's good. Still have a moderate drought in parts of LaFleur County. I actually forgot that today was the drought monitor that was released. It's hard to remember everything for sure, but very dry, and we go back to that. And so there's a look at La Nina, and then if we look here, another example of La Nina, you have the trade winds. This is what causes it, by the way. Trade winds blow east to west, push warm surface waters towards Asia. However, in certain years, those trade winds are stronger than usual, causing the waters to basically cool in the Pacific. And then what that does is that provides that type of weather pattern. So that's the winter time. And notice that sometimes those tracks, that's a little too far north on that track. But that's how that works. Now, El Nino is totally opposite. And I think I got a graphic for that. Here's an El Nino winter. So wet, but not a lot of snow. We got the subtropical jet that's a little bit more active. The polar jet's a lot higher. And you got a low pressure system to the northwest. So that's why the West Coast is so wet. And I'm not saying that this is the end all be all of, of everything, but this is what happens with an El Nino. So you have warmer than normal waters near the equator in the Pacific Ocean. And then what that does is that creates the jet stream pattern that you just saw, an active subtropical jet, a lot of rain on the West Coast, and dry conditions in the north. So that's a good question. Why does the jet stream flow west to east typically? It does with our type of weather pattern, and you get what are called cells. You get the Hadley cell, Farrell cell, the polar cell. And at those areas, you get different winds. That is a good question, though, about the jet stream. So remember those trade winds. The trade winds are essentially what brings the systems near the equator. You have a circulation of the air from the northern and southern hemisphere. So if you look at that, you can see that when you loop a global model, as a matter of fact. So we can do that real quick. I'll show you something real fast. So we'll go into weather data. We'll go into satellite radar. I gotta zoom out on this. Okay, stand by. Global sector, a full disk. That's kind of terrible. Hold on just a sec. Goes west, full disk. And so if I loop this, and we'll go 200, I can animate it. And I'll do water vapor too. So this will load up. Get to see the way the winds flow. So the atmosphere is a fluid. And it's also due to the Earth's curvature too, as well. So yeah, here's a what's called a full disk. So there's a full disk image. That is in the Pacific Ocean. You can see all the active energy and all that stuff. So yeah. Then you can see also too westerlies, a lot of westerlies. You do have a little bit of trade winds down here. See how that's working right there? So if we go to a different sector, let's go to goes east, load up a full disk. Now you'll get to see we have in our term, in our environment right now, we have a pretty active jet stream and a very progressive weather pattern, which is why hurricane season has come to an end, basically. Number one, the water temperatures. Number two, you got all these systems that are coming in, but you don't have those trade winds anymore. They're pretty much gone. And so that's exactly pretty cool stuff, though. But yeah, jet stream is an interesting thing. It's caused by temperature differences at the surface. Those temperature differences at the surface ultimately vary everything that's happening. The jet stream isn't real. Okay. Next time you see those clouds rolling in on Sunday, you'll see the jet stream ripping in. So, all righty, guys. Well, I'm about spent. And by the way, I only have one more day, and I'm going to be off for several days. So I'll be off, honestly, for the rest of the year almost. So anyways, I'll have one more Facebook Live. We'll dive into it tomorrow. And I appreciate it. Thank you so much about that, about the interesting information. And yeah, she's probably asleep by now. But anyways, you guys take care. Thanks so much for tuning in and geeking out with me. You know I love talking about the weather. Tomorrow we'll dive into it one more time. Let's see. One last question. One last comment. We cannot close on real estate if there's a storm in the box. Do the inevitable storms in Arkansas affect insurance writing? Not really, because our storms aren't as, like we still have risk, but it's not as great. So, but anyways, wow, is that screen flashing? I think it is. Okay, guys, I got to run. Snow day for me. Yeah, a lot of them. I can't wait. We'll talk to you guys later. You have a good one, and God bless, and we'll see you tomorrow, and we'll have a better idea on that potential for a white Christmas later.